Hello.
Hello.
How are you?
Very good.
Hear me?
Early morning.
Perfect.
Yes, I can hear.
Nice to see you again.
Can you hear me clearly?
It's difficult to see here. I just
Um,
don't see all the participants here, but it seems to be quite a few.
sure. Right. Frederick, can you hear me clearly?
Yes, I hear you very well.
Yeah. Should I try the share screen? See the
Yes,
PowerPoint work.
please go ahead.
But the organizer need to authorize.
Okay, I can see here who can share all panelists. Sorry, it's saying all panelists here. So I will see if I can yeah, I will make you as a host. Yes.
Okay, let me give you a try. See if it
I did it now.
work. Can you see my PowerPoint right now?
Yes, right now we see your background on the screen and your PowerPoint. Yes, now it's the full.
You see the title, right? Can you see that?
Yeah, now it's in full presentation mode.
Okay, that's good.
Yes. So I think we should start in 1 minute.
So Frederick, how long do I have for the talk?
I mean, the session in total is I think it was around 100 minutes or exactly. So you should have around 50 minutes then. But I guess it's good if we have time, if we have some questions also from the audience.
Right, I think that's good. So I'll try to manage that. 40 minutes, 45.
Yes, I think it would be good with probably around 40 minutes. So we can have some discussion. And also I get in the end there is another presenter that needs to be connected as well. So I think 40 is probably the maximum.
Okay.
So I think sorry?
Yeah, I'll try my best.
Yeah, that sounds great. I just want to introduce myself. I'm Fredrik Wallin. So I'm working in Sweden in Mälardalen University as a assistant professor there. And so I will be moderating this session. So first we will listen to Professor Perry Young, who will give us a talk on urban system design for low carbon urban energy districts. And you have some cities where you go into depth. So Perry is the director of Eco-Urban Lab at Georgia Tech. So he has been working on incorporating data analytics and into urban design kind of questions. So he has published a lot in the area. And what could be mentioned also that he was awarded more than 10 prizes, among other the 2009 World Games Park in I don't know to pronounce it, Huaqing, that was hosted by the CNN as an eco-friendly venue. So it would be nice to hear your talk, Professor Young, and please go ahead whenever you feel ready.
Right, thank you, Frederick. Welcome to the session. It's my honor to be invited. I'm no stranger to applied energy. I have been participating in ICAE for like 5-6 years, kind of focusing on urban energy. So this is a great pleasure to be here. So today I'd like to share with you the kind of more from the perspective of urban design to look at how we contribute to this urban energy agenda. So I'm planning to talk about 3 cities, Tokyo, Shenzhen, and Atlanta in the US. And pretty much based on the 4 dimensions. First one, I'd like to talk about data-driven city, and like to see how we use big data analytics for problem like mobility energy, like even human perception. And moving to decision platform, how do we develop digital platform for decision for lower down our energy emission, and carbon emission. And finally, I will cover some example how we move from conceptual model to implementation. So I'm from Georgia Institute of Technologies as an urban designer who is interested in urban energy research. So let me give you a bit background about the whole thing. I think urban design has been contributing to city building for like more than a century. You can see the paradigm shift has been happening. For example, like early 1920, when we just have a car, right? The Ford Model T, like a century ago, that fundamentally changed the way we design city. For example, the modern city model, like Le Corbusier, high-rise motorway, greatly influenced by technology. And later on in 1950, say in the United States, there was an enormous infrastructure, like interstate highway system. So you can see today, our problem, like people biking, walking, competing with car. I think that's, and we are consuming so much energy, gasoline, and produce carbon emission. Then we are moving to the paradigm number 3, which is where we are now. We are emphasizing pedestrian-friendly walking environment. We encourage walking, not driving, in order to reduce transportation energy. So this is where we are. And you can see the right-hand side, number 4, is where we are moving toward in the next decade. For example, electric vehicle is becoming pervasive. Autonomous vehicle, they will be fundamentally changing the way we walk and bike and live and play in the city, even flying car, urban air mobility. So it becomes a shared infrastructure. So urban designer and engineer all together, we need to look at what future cities should be organized in the future. Near future is coming. So that background gives us some inspiration about smart city. How do we design smart city? What are the basic questions behind? So my discipline is experiencing a major change. Urban design and city building are becoming data-driven. So we have enormous amount of data. They are driving a lot of business, industry, and decision-making. So how do we make use of data science, pervasive computing, Internet of Things, like an urban automation, like as I mentioned, AV and UAM. So the first question, I think, is something we all focus. How does urban system design and engineering, for example, enhance energy efficiency and resilience in urban environment? So I like to emphasize a transformative approach. We don't just analyze what it is in the system. How do we transform the system by integrating design and performance evaluation, like energy performance, for instance? This is a very straightforward question. And the second question, how would data science, for instance, and those emerging technology would change the way we design city? So what I mean in this question is data science, for example. In the previous few days, there are a few research papers using AI, using reinforcement learning, like model-free method to process big data. And so how with those data science, like when we derive property from complex system using big data and come with some kind of general principle, predictive model, or even prescription, how would those principles being applied to other cities? They are in different climate, urban, social contexts. So there's a kind of a from the inherent kind of contradictory thing. Can we apply the principle we learned from Boston, apply them to New York, Washington, DC, and Atlanta? So there's a very contentious issue right here, right? So it doesn't mean that you process big data, you get an answer. that you want for your specific problem. And the final question we have, I think I'm particularly interested in this final question: what generates future urban form of smart city? I think, is there any new innovative way of designing city that give us a very different kind of city that fundamentally change the way we live and work and play? So these are the questions behind the talk today. And right-hand side is the book that I jointly published with Dr. Yoshiki Yamagata. He was a keynote speaker last year at CUE on urban system design, using this IoT technology to look at how we design a larger scale system. So the first example I like to introduce is Tokyo. I have been working with those partners in Japan, given this conference is now to be in Japan. And we have been working on 4 different communities in Tokyo Bay from 2017 at Urawa Misono, one of the main stadium for 2020 Olympic Games. And we moved to the inner city neighborhood called Kyojima, Sumida Ward. How do we do the neighborhood renovation? Like there are lots of energy problems. And moving to Shinagawa, the new MagLab high-speed train station in Tokyo, there will be new gateway because of MagLab high-speed rail system in Shinagawa. And moving to the new project from this year called Nihonbashi, which is located at the historical center of Tokyo. And the project will be sponsored by Mitsui Fudosan, one of the biggest developer, their endowment in University of Tokyo. So this is the experience that we have been accumulating for the smart city experiment in Tokyo. And there's a kind of historical background I can share with you, that Tokyo has a kind of legacy about urban design development. This is a famous architect, Kenzo Tengi, who was a professor in the University of Tokyo, and he visited MIT to develop this model called Plan for Tokyo Bay in 1960. So like many decades ago, they envisioned city as an urban metabolism. So in which you have energy, water, material, human flow on this large, enormous scale. So this is like 90 kilometer new city on top of Tokyo Bay water. In the context of post-World War II Tokyo, reconstruction of Tokyo and the growing population, how would Tokyo accommodate additional few million, like 5 million population? So they have this utopian like proposal in Tokyo Bay. So we see the city as a complex system was proposed in early day, like city like a flows of people, movement, and of course water, energy behind. And so that the flows in 1960, they mean motorway, like driving all the way across the region. So it's a transportation infrastructure that define the framework and the growth of city that can grow over time. So that's 1960. And what about today? So today the city as a flow, the infrastructure is different from like 1960. That's what we have. We have flows of people. This is the kind of GPS data we have for the Tokyo metropolitan area. Only 2% of GPS data. So it's a flows of information, flows of data that represent how humans move in the city, how city is organized. And we like to know the energy performance, carbon emission based on this huge infrastructure. So that 2% GPS data give us the kind of big data condition. How do we process the data that is massive and that is dynamic and very noisy? We have all kinds of data. They come in different formats, and a lot of data they come in near real time. So how engineer, planner, urban designer, policymaker capture those big data, and how do you utilize those big data and apply with different kind of analytical technique we have on energy, water, transportation to understand their total performance. So you can see this is 37 million population Tokyo the biggest mega city in the world that we are looking into. And so with that in mind, and I can give you some example. So that big data, for instance, at the left-hand side, give us a new condition. We need to engage the super fine grain, kind of very detailed spatial and temporal data. For those real-time data, like right-hand side, when you zoom into the neighborhood level, this is the stadium for the 2020, actually 2021 Olympic, one of the main stadium in Urawa, Mizuno. So those big data were taken. We classify those data and then run, say, traffic modeling. And using predictive model, we find out where are the traffic jam that would occur at, say, 5 to 7 p.m. at certain location. And it actually happened in that way. And you need to have your digital platform to accommodate all kind of data information from topography, water, road network, building, human, and zoning. For example, there's a regulation about land use zoning behind. And that data, for instance, one dimension is about walkability. For example, those GPS data, we use machine learning to classify them and to find out, are they actually walking? Are they taking public transit? Or are they driving? And using those techniques, we can even predict, are they doing sightseeing, doing shopping, or doing resting in the city? So that become very interesting. So like human activity influence the way of time schedule for energy, and how do we see they happen indoor and outdoor will be important for urban energy research. And if we go further, we'd like to know city as a dynamic setting, how people walk in city. When you walk from point A to point B, what do you actually see? And why this is important, because we like to see city is a very different platform like than 20, 30 years ago. And so how human perceive the environment, how humans sense the environment, how human walk the environment, experience the environment, and react. And you are capturing information, how you react, respond to environmental information will be critical for some climate resilient problem like heat wave attack, for example. When there's a disaster, how would people being informed by near real time? So I think the image of the city is something we are focusing here. You can use machine learning. We use the pyramid scene parsing network to process the image of the city, the picture, the streetscape, like Google Street Map. You can process them, and using machine learning to how much green space are you seeing when you walk along the street? How much sky is opening? How much building facade? What kind of information you can capture? And you can actually using data analytics to process that. And also, we like to look at the performance of a city. And we believe that carbon emission, that before 2050, many cities like to be carbon neutral. And you can see that urban carbon mapping and modeling that my partner, they come with this model for the community is a combination between building energy and transportation energy. So how much energy is consuming in different sectors, how much carbon emission you can actually measure, monitor. And more importantly, we like to know, how do we do mitigation? How do we mitigate the energy consumption and carbon emission down to near zero, actually net zero before 2050, like in many cities like Tokyo, London, and so on. So what kind of design strategy should we bring into the community and district in order to enhance the energy performance will be critical. So this is the slide to end this Tokyo example. And so the problem is complex, right? The problem is not only about physics of building. The problem of smart city engage social, ecological, and technological system. For instance, this is the community that we look into in Tokyo, in Kyojima. So the community, you can see the problem like aging society, flooding. There's a lower ground city, and the street network is very irregular, organic, because they build a city, the neighborhood on the farmland. So those street network They're pretty much like irrigation system a few decades ago, before World War II. So that neighborhood has a big problem. For example, the streets are very narrow. They are organic. So when there's a disaster, say earthquake, kind of emergency, the fire engine, ambulance, they cannot drive into the community. The street is very narrow, but it's very walkable on the other hand, right? So the government has been trying to widen the road for emergency purpose. So we came with a different idea. We talked to the district government. You don't widen the road. What about we bring in the new technology like Toyota? They have an e-pilot autonomous vehicle to go inside the narrow street. And we turn the street into the pedestrian-friendly walking environment with landscape, with the autonomous vehicle. And they can help processing the logistics like food, emergency. And that's so it's a very complex system when you design a smart community. And so they engage different dimensions. So how do we come with a design decision platform to integrate those different stakeholders with different information? So that give you the first example that we have in Tokyo. And the next example I'd like to show you is a campus design in Shenzhen. So this is the project that I was involved with. My university, Georgia Tech, we have a 3-party agreement with City of Shenzhen, the Shenzhen city government, and Tianjin University to build a new campus, I think nearby the high-speed rail terminal of Shenzhen. So this is like a global campus of Georgia Tech that's going to be starting from this year in terms of design construction. And so we'd like to bring in the green building, green campus concept from Atlanta to Shenzhen, which is the kind of amazing, innovative city like Shenzhen. So you can see the site is like now empty, like the empty site with the topography and so on. So I was involved with some of my colleagues in Georgia Tech to come with the so-called campus planning design and see campus as a complex urban system, as a small city, as a small scale complex system that's composed of landscape building infrastructure. And so we like to focus on like energy issue, water, transportation. How do we design a smart campus? So there were 3 approaches being taken for this. We have designed by designers, idea, anticipation. We use system optimization. And again, we look into the decision platform for the campus design. And there are some questions behind, similar questions. What generate campus design? What principle can be taken for making design decision to be low energy, low carbon, for example? How do you optimize design option based on with different multiple criteria performance objective? And how do we manage the process? It's a very complex process from scenario making, performance, optimization to decision making. So the first approach we have is called design by anticipation. That's the traditional design approach that we use, like as an architect, urban designer. Say we come with concept, right? So we look at the site, we use understand the site context with topography. We know the program of a campus, 3,000 students, classroom, library, auditorium, and so on. And we have a concept. And our concept, like for example, to avoid the topography, to concentrate the building into the flat area, or we develop a cluster, like a courtyard space, or we decentralize the building across the whole landscape. So you come with the design proposal or scenario based on context, say site context, based on content, say the design program, what 3,000 students, what is the need of user and the concept. So that's a very typical approach by urban designer by defining the problem. And we look into the site context, say topography, water, climate issue, and we look in the program, how many square meters for different spaces. And we have different concepts to come with different scenario, A, B, C scenario. And then we evaluate their performance. For example, how much energy demand. And if you apply solar PV on rooftop, 50%, how much renewable energy you can produce. Because we only use like 50% the conversion rate, we're assuming like 12.5%. So you only got 14% renewable rate for one of a scenario. And that is very limited. kind of idea to understand the problem. So we think we should do further. We bring in another approach called generative design, using reinforcement learning, using that agent environment kind of interaction system to look at the problem. For example, topography. We don't build high density on the slope, steep slope. And we have a slope analysis. When you have a kind of gentle ground, you have higher density, you have better, more building footprint. So using some rule behind, we use that to generate different kind of possibility. We don't just produce 3 scenarios, we produce like almost 100 different design options. Then we like to know what kind of performance they have, energy, on solar availability, on visual quality. And we use multi-objective optimization to use Pareto front to look at optimization of your design option. So you can pick up limited option based on a few hundreds possibility that produced by parametric design. So there's a paper published in Applied Energy, this journal 2019. You can look at how we do the generative design and multi-objective optimization. So that's again show us that city or even campus as a complex system is exhausting, right? There are lots of possibility. How do we make decisions? So in reality, when designer come with scenarios at ABC, how do we make decisions? And the client or stakeholder say pick one of them. So that's a very traditional approach. We like to understand the energy performance, for example, but they are also very limited. So you go to the stakeholder meeting, we meet with our partner in a university and participant using different collaborative process to get more opinion, and you come with many opinions. So you can possibly make decisions easily based on those limited options. So we apply both traditional approach designed by anticipation and design optimization to give us a reason why we make that decision. And we go further and we realize smart campus as a small urban system is very it's exhausting. You have all kind of information like nature environment, you have water, wind, you have a built environment, you have a space between building, you have a sky opening, daylighting, and you have user, occupant, they have a different energy scheduling, they produce energy demand, and you have a renewable energy possibility, and you have a mobility issue. So it's a super complex environment, and it's almost impossible to optimize that system. So we decided to use a more passive role. Instead of designing a campus like an energy efficient machine, right? A complex system, we designed a framework for collaboration. For example, from phase 1, phase 2, phase 3, from planning, design to construction and operation of the campus. And we invite a lot of research center laboratory to be involved. So there are people doing like digital twin, zero energy building, stormwater management, robotics, big data analytics. So different researchers ask different research questions and come with research design driven by common goal. Can we make this campus to be net zero energy, net zero discharge in the long term? So you bring in, you develop a framework, you invite different bottom-up approaches, participation to enrich your smart campus. So that's what we do. So that is another example I would like to share with you. And the third example, I can make it very short because it's the project, and we just began that project for about a year. In Georgia Tech Eco-Urban Lab, we are working with aerospace engineering, aerospace system design laboratory, and also with the partner like airport in Atlanta, Hartsfield-Jackson, Atlanta International Airport. They are the biggest airport in the United States. They have about 110 million passengers in 2019 before pandemic. So in average, we got about 300,000 people every day coming to stop by this airport. And we work with Atlanta airport community improvement district, which is like a semi-government. They are doing infrastructure system for the airport surrounding. And we work with Metro, rapid transit system company called MARTA. So with those stakeholders, we are like to look at future airport. When airport is attacked by pandemic, so run down with, so how do we redesign airport and city to be safer, healthier, resilient to the shock and the problem. So the concept, one of the concepts is called airport city. We call it Aerotropolis. And to look at many global cities, they are turning their city airport into so-called airport city, in which a city center are built around globally significant airport. We call it Aerotropolis. So these are the example of like Doha, Hong Kong, Amsterdam, Schiphol Airport. So you see the area around airport as with great opportunity for new urban development. And London Heathrow, they bring the people rapid transit to the airport. So this is something we are looking into. So Atlanta Airport is an economic engine, is a job center. So around Atlanta Airport, like 5 miles, 10 miles radius, there are all kinds of industry. There's the aerospace, logistics, food industry, and so on, life science. How do we understand those job center? How much job are created around, and look into the problem. So there's a social issue that the city government is very concerned. For example, a lot of low-income employee, their job are around the airport, but there's a problem of spatial mismatch between the job and where they live, and they have no access to the public transit to go to their job. So how city airport of Atlanta develop new infrastructure will be critical for this problem. So we are looking into the potential topic called autonomous aerotropolis by bringing like people rapid transit, by connecting the terminal, domestic terminal, international terminal, and also going through different community around the airport to benefit the community and economically and socially. So this is what we are looking right now. And at this point in time, the Georgia Tech research team, together with the airport CID, we are looking into the parking space. There's a huge parking outside of the airport of Atlanta. The size is similar to Midtown Manhattan. So you can see the huge amount of land are wasted. They are using that for parking, surface parking and elevated parking for the airport. And that's the main revenue that the airport rely on. But given the impact of new technology like electric vehicle, in the US is moving, and autonomous vehicle, even flying car, how do we reconfigure, redesign those parking spaces by bringing the new PRT system and using transit-oriented development to reconfigure, reorganize the airport city to be safer, healthier, energy efficient urban settings. So that we use agent-based modeling to simulate what is the impact of new development around the airport with the people rapid transit to impact the way human move. And we also kind of doing the next step. We are monitoring kind of the data, also projecting the future energy performance, carbon emission for different scenarios. So very quickly, this is what we are aiming for, to develop a design decision platform for the future airport city as a digital twin. But it's difficult to develop a truly digital twin because we are projecting the future design. So basically you have a situational awareness of the short term. You get data inside the airport, outside of airport, the mobility issue, traffic management. You use predictive model to forecast the traffic, to explore the problem like mobility between the job and housing. And we'd like to look into the midterm future by bringing PRT, people rapid transit, autonomous vehicle, flying car to the parking area for long-term strategic planning. So digital twin will be a good, important platform for integrating those information for the airport as a complex system. So I had to have a conclusion here for the 3 examples. The 3 slides. The first one, we need a decision platform for city as a complex system. So we capture data and data are unstructured or structured. You have social media text data, satellite image, street view data, mobility, traffic, building energy data of all kinds. So they are massive, they are dynamic, they are very noisy data. How do we process those data? And we need different kind of performance indicator behind. Say we like to address problem of heat wave, energy, flooding, carbon emission, and accessibility, and so on, and develop some toolbox, some data analytics and modeling toolbox for making design decisions to communicate with stakeholders using AI behind you, algorithm to help you process those data. And how do we move from model to implementation and see smart city as a living laboratory? This is what we did with our partner in Urawa Misono for Tokyo 2020 Olympic site. So you have about 3 square kilometers site as a living laboratory. And there's an IoT infrastructure from small scale device person building to town center for flooding, energy, safety problem. And the government designated that area as a special energy zone. So they are targeting on net zero carbon emission, renewable energy for the specific area as a living laboratory. And the government built up an urban design center, which is an urban data center, by collecting data, they capture data on site for the problem of the community and turn them into business opportunity. And this is my final slide. How do we move from model to implementation? So in the case of Tokyo, we learned we need to integrate community participation. We have engagement with stakeholder community and come with design alternative scenario. And those alternative urban design scenario, we model them. We like to understand how much energy performance, how much human comfort, workability, and they can get. So we like to design a green community, ecological energy, high performance community, and to get certificate, like they get LEED neighborhood certificate. And the reason why the government need to get green certificate, because for finance, there's a green bond mechanism in Japan. You can apply the funding from green bond if you can prove that you are green community, which means you can use certificate of green community to go for green finance. And how do you get green certificate? Because you prove that you are designing ecological energy efficient community using your urban design and participation. So there's an idea to move from model, the research we do on building energy, urban energy, to implementation by that integration. Okay, so thank you very much. I hope that is useful information for sharing. Thank you.
Thank you, Professor Yang. It was really, really interesting. I just wonder, I think just from a practical perspective, I think I made you as a host when I allowed you to take over and open up the presentation.
Sure.
So I was hoping that you could remake me as a host again.
Oh, okay, sure.
I should probably have selected co-host when giving you the. So do you know Zoom? So you know how it works? Professor Yang? So I think if you go into the participants and then you take the panelist tab.
I already go to participant. I think you now have authority to do things.
I think you should, because you're so to say the host right now.
Maybe organizer
the panelist names
can help. I don't see anything I can do in.
I think the audience can raise their question in the either chat or the Q&A photo. there's a panel there. They can write, but I don't think
Yes.
they can speak because I was logged in as a participant. It's not available to. But now it's the same, so I can speak, but I was not able to do that. That means a participant cannot, because this is basically the webinar setting. But any all the participants, if they have any question, they can always raise by writing as Q&A or chat.
It's
Any
saying
question?
I was a little bit curious, Professor Yang, regarding,
Yes.
I mean, regarding the data collection challenges, as it's usually a lot of challenges to, how have you been working in your projects to get access to data and to, I mean, to connect the data with the geospatial kind of mapping, and has it been challenging? And do you see different challenges in the different cases?
Yeah, I think we, in the case of Tokyo, there are lots of open source data. And since we are working with local government, there are lots of spatial data we can get. And open source data, a lot of them you can, like building road infrastructure, social media data. And those are data we get, like GPS, Google Popular Time, for example, right? Those are the data that you can get from Google. But there are some data that can only be captured locally on site. For in the case of Tokyo Misono Olympic site, so there was a IoT infrastructure being managed by Urban Design Center, established by local government. So there's a server in the Urban Design Center. So they like to control the data, use the data for their own purpose. So in 2017, when they began building this Urban Data Center, IBM came to them, said, can we sell you smart city package? They said, no, we are going to capture our own data and turn those data into useful application for the community. So there are certain data that can only be captured, owned, and even controlled by local community, local government. And I think that's what's smart. And there's a policy from government to designate that area as a special energy zone. So which means they got some special regulation they got authorized to do some new experiment. And so that's, so you need to combine different kind of data sources in that case.
I think I see that we also have a question here in the chat. My question is, what are the challenges of an airport city? Are they also designed to be a prosumer in terms of energy?
Yeah, for example, in the city of Atlanta, the city of Atlanta has already determined to turn the city into 100% renewable energy before 2035. So there's a policy moving this renewable energy. Atlanta has not yet announced to be carbon neutral before 2050, right? Like Tokyo, Paris, and others. But there's a renewable energy agenda moving. And also, like recently, Biden administration, they are pushing for electric vehicle. So there are lots of EV infrastructure need to be designed and developed in city area, like airport, right? So those are opportunity that airport and the local government around the airport to work together to redesign the infrastructure, pretty much based on this energy carbon agenda, right? And so I think that is central issue for Atlanta Airport City. We haven't achieved much because we just began to work with this project from last year. So it's a very exciting opportunity for that.
Yes, I do understand. Do we have some more questions from the from the audience or from the participants? Seems to be no more questions. I think we still I think we might have a small technical challenge. Yeah, there is a question.
Okay.
So can you? I don't see it. Yeah. How do you incorporate in this kind of models other economic variables like energy prices, congestion prices, income, etc.?
I have not yet addressed those issues. I know pricing is the important mechanism. Pricing incentive, they are important in the model. So we are pretty much focused on the physical dimension, making design options, scenario making. Our modeling pretty much focused on building energy and mobility, and to some degree, the human perception modeling. And so I think economic variable are critical for the implementation. Is a very good point. Yeah, I like the question.
Yes,
yeah, maybe I can have one question. Is per se is more general. We have been discussing this for quite a long time. You know, the urban planner architecture is one field, and engineering implementation even come to the building in the rooms, and how those two parts of the people can working together. We are trying. There's a lot of discussion, but still, I would like to hear if you have some.
Yeah, that's such a good question, Professor Yan. That's also one part of the reason I joined ICAE, International Conference Applied Energy from 2014. That we like to learn. I think as urban planner, designer, we like to learn from energy expertise offered by engineers, scientists, even social scientists. So I think urban planning has been, in the US context, looking at process, how we engage community to get consensus. But I think urban planning should move their focus to system at the same time and understand the complexity of urban system, and in which energy is central. Energy is such a central issue for understanding interdependent relationship between different sectors, different infrastructure sector like water, energy, food, and so on. And so that is something the urban planners should be learning, and to understand better how complex system function and what kind of decision can be made. So I think that collaboration is really important for addressing our problem today. I think a lot of planning school, they are paying a lot more attention to this climate energy problem than 10 years ago. And I can see like I have some observation since I joined that international ICAE from 2014. There's an increasing number of paper. Their interest is now in urban category. So that's a very exciting move. I think organized by Applied Energy. Do I answer the question well, Professor Yan?
No, thank you. It's very, because that's also a different field and people working in different approaches. And but very good, you have pointed out data-driven approach become more plays the impact. I believe this can be somehow very good linkage between the urban planner, designer, and also the engineering. And because that's something which can do not only in the sketch of the nice picture, but also be able to implement in buildings, in street and transportation. So that can be a very, very important area for us to explore, both from the urban planner, designer, and also engineers.
Right.
Yes,
And if we look at the,
some.
yeah, I think that's a very good point. If we look at the paper, I think there's a enormous amount of literature on building energy, but we can see the growing interest on urban or community scale energy problem. And I think we like to make an argument that maybe we should focus on the community urban district campus level, because they are much more designable than the larger city. And it is bigger than a building scale, because you understand the property of building is important, but when you like to have a bigger impact, you need to scale it up to a certain level. So there was one discussion 2 years ago I had with Professor Yan to talk about 10 square kilometer. We maybe need to define the optimum or the right scale for research in order to connect the scale below and the scale above.
Yeah, very good point. It's a showcase and or best practice is always very interesting to introduce.
Okay, any other question?
I think we maybe need to